this question, and it took me about 15 minutes to get an answer. And I'm not even asking for like a perfect answer or anything like that. I just want some type of brainstorming to come up with it. I asked the children what a radical was. And considering that I have this up on the board, I'm pretty sure you guys should take an educated guess. Yes. The thingy in the red, okay, yeah, that's actually, believe it or not, that's actually better than what I heard last period, but yes. Huh? Nothing. I heard crickets. There was even a tumbleweed. I don't know if it came out of nowhere, like just went across the room. I was like, I thought it was kind of bizarre. I was like, wow, maybe somebody left the door open. But maybe. It's Atlanta weather, there's all sorts of things. So you never know. Okay, but now instead of calling it the red thing, is there something else that we might want to call it? Yeah, Taiwan. Okay, yes, Emma. Well, yeah, but let's try not to use the same word as the definition. It looks like a division thing. Hi, how about this? What do you think most kids that come into an Algebra 1 class call it, based on their previous experience? Which isn't entirely incorrect. It's just not a check mark. No, that would be more like what maybe a middle school kid would call it. But what do you think? You're right. But I'm saying like going into middle school, maybe they might call it like a check marking thing that I've seen in my calculator. But since you guys have seen it before, there's usually something that, I mean, I'm not just making this up. Like I've taught this class before, and there's one thing that most kids usually call it when I show them with the radical. Like at least it looks like you've been able to identify, you know what I'm referring to. But now let's try to use your words and see if you could tell me what maybe more kids refer to that as, so that I can then point out the differences between that and a radical. Yes. Division. Okay, well, no, it's not division, no. Well, we're getting there. It's got one of those words in there. She said perfect square root. Thank you. Yes, that little check marking thing. The first time that I introduced it, most people, oh yeah, the square root. Well, no, every square root is a radical, but not every radical is a square root. The radical is the symbol itself, the check marking thingy that looks like division. But yeah, the symbol is called a radical. But the type of radical is determined by what's called the index. On the little perch that's on the outside of a square root, there's always a tiny little number there. But wait, what are you talking about, Mr. Romero? Did you hit your head this weekend? I've never seen a number there. Well, yeah, because if you don't see it, there is a number there. You just don't see it. No, it's not a 1. Think about it. They call it a square root. 2. Good. When you don't see an index, the index is 2. Dave, you're making more friends? Don't you have enough already? No. Try to be less popular. It's hard, but you can do it. So, all right. We just did like a subunit on polynomials. Here we're doing a subunit on radicals. You actually have a quiz on this on Thursday. Then you have a test next week on both of them. Yeah, that's what the test will be on. Okay. But as I've told you in the past, short of just giving a grade away, I want to present every opportunity for you guys to pass so that you don't have to repeat things. So you saw some of the measures. We took a multiple choice quiz last week. Some of the material is a little bit simplified, no pun intended. When we do a unit on radicals, yeah, like we have to establish this today because this is going to be used every day this week. But we'll move on to adding and subtracting. We'll do multiplying. But one thing I'm not going to do that you probably did last term is dividing. Dividing is where this gets really tricky, but we're going to just stay away from that. We're going to keep things simple. Everything is simple for Xavier. He leads a simple life. He's a simple man with a simple life. Uh, so what we're gonna learn today is just all right. If we're not adding these things, if we're not multiplying these things, subtracting them, how can you just do the radical itself? Just like adding, subtracting, multiplying, dividing. A radical is an operation. It shows up on the calculator. I would love if you guys had your calculators and brought them out now. That would just be dandy. And if I were to compare a radical to another operation, I'd probably pick division, and not just because of the appearance, because you guys said that it looks like that long division sign that you did back in elementary school. But unlike adding, subtracting, and multiplying, sometimes division can't be done, or at least it can't be done completely. So, like for instance, here if I were to say 4 divided by 6, can you divide 4 by 6? No, because if you put that in the calculator, what's it going to give you? It's going to give you a decimal, not only a decimal that goes on forever. And even though it repeats, the only way you're going to get it from the calculator, the only way that you're going to get it onto the calculator is from the calculator to the paper is to round. Oh, wait, Mr. Romero, but my teacher taught me I can draw like a little line on top, and then that would help. No, that line is useless. Okay. And what you'll find today is that sometimes the decimals don't repeat. But anyways, the point I'm trying to make to you is with division, even if you can't do it completely, sometimes you can do it partially. Xavier, whose legs are back in the row again. If I can't divide these two numbers by each other, is there some other number that I can't divide them by? By 2. And if I divide each one by 2, that gives me 2/3. What have I done? I knew that. I've simplified. That's what I was thinking in my head. Cool. Facts. I simplified division. So the same way you can simplify division, we can also simplify radicals. But in order to simplify radicals, we have to know what a prime number is. What is a prime number? I think you read that beautifully. As bad as first period was with that first question of what's a radical, I actually got this answer a lot quicker than I thought I was going to get it. When I asked what a prime number was, one student knew it really fast. So, besides what's written on the board, in plain speak that everybody can understand, what is a prime number? Very good. It's a number that can only be divided by 1 in itself. Okay. When I write that the only factors are 1 in itself, it means that it can only be divided by 1 in itself. What do you think prime numbers are frequently confused with? What are prime numbers frequently confused with? I've given you, these are some examples of prime numbers for you to look at. There's an infinite amount. It goes on forever, but those are the first few. Odd numbers, very good. With the exception of 2. Okay? 2 is the only even prime number. With the exception of 2, every other prime number is odd. But not every odd number is prime. Can you give me some examples of some odd numbers that are not prime? 9. Would you say, Rosalind? 15, sure. 27. 33. 49. 25. One actually, and you know what? No. For years, I thought that I assumed 1 was prime. And then when I actually looked up the definition, it is like, because you would think, hey, 1 can only be divided by 1 in itself. Yeah, 1 would definitely not be composite. That's a number that's not prime. It's composite. I always thought it was prime. It's just neither. It's neither prime nor composite. Facts. Just there. Yeah. So here, let's do some examples. And then maybe since we didn't waste as much time as we did last period, maybe I can even do some from the homework for you. So since you took out, I want to take the square root of 90. And like any other operation, many of us have become very, very reliant on the calculator. So I would tell you, okay, this should be no different. Square root of 90, bam, put it into the calculator. And unless you have a fancy feature known as math print, it's going to give you a decimal. Soha, yours gave you something different? Yes or no? No? Decimal? Okay. Yeah, because some people have math print. Like, it looks like he has math. I'm still learning names. Nico. Like, it looks like yours has math print. So yours is probably going to give it to you. It's going to give you the answer that we're about to get here. But, we want to avoid the decimal. When we try to take the square root of the entire 90, it gives us a decimal. So maybe we can just take the square root of part of the 90 and leave part of the 90 in. So this is where we want to do a prime factorization, or what you may know as a factor tree. Now, let me ask you a question first. How many of you here feel that you are very strong with mental math? You feel that mental math is one of your strong suits. You feel very, very good with it, comfortable. Xavier, you would, okay, so we got one. Okay. That's why he gets all the ladies, Taiwan. They walk by and they're like, man, look at the mental math on him. That's why. So, because the reason why I ask you that is because the way that you've been shown in the past to do a factor tree, I can almost guarantee you the method is heavily reliant on mental math. So I'll show you what I think the structure that you've learned it before, and you tell me if it's any different. So on a number like 90, which is what I want to put into a factor tree, more than likely you learn by saying, hey, 90. Well, do you know what? I know that 90 is 9 times 10. Oh, wait. I know that 9 is 3 times 3. And I know that 10 is 2 times 5. And yay, everybody lives happily ever after. Has anybody learned to do a factor tree different than this? So, look, and it isn't even, I know it sounds maybe like I have a problem with this. I don't have a problem with it. I just don't feel, for most students, not just you guys, for most students, I think it's not suited to your strengths. Okay, for me, the weaknesses here is a lot of kids make mistakes. They don't know when to stop the tree. They don't know when the branches can stop expanding. And then number two is the big one, what I asked you first. It's too reliant on mental math. Yeah, this works great with a number like 90, but then how about if I wanted you to do a factor tree with 3,284? Are you going to tell me off the top of your head two numbers that go into 3,284? Yeah, probably not. And if there is one, it's going to just be two. You're going to look at it and say, oh, that's even. I know two goes into it. Which then I would counter with saying, okay, perfect. Well, that's the way I show it. So, like, the method I use, it's not even because it's easier for me, it's more for you guys. It gives a little more structure, and it's more conducive to being used with a calculator. So the way I teach is, all right, look, I gave you a list of some prime numbers here. There's obviously more than that, but if you can at least memorize these, that's off to a good start. Okay. Look at 90 and say, is 90 even? Okay, so let's start with 2. Instead of dividing, 9 times 10, let's only stick to prime numbers. Every integer can be rewritten as a product of primes. If you give me any number off the top of your head, I can give it right back to you as a product of primes. What does the word product mean? Answer, no. What does product mean? Yeah, there you go. That's the main word, multiplication. It is the answer for multiplication. Yeah, but just the multiply is the key there. That's what Emma said. You can give me any number. I can give it right back to you, multiplying primes. So let's say, all right, since 90 is even, I know I can bring out a 2. But wait, Mr. Romero, I don't know what 90 divided by 2 is. Okay, well, if I mean, I do. But if you don't, your calculator does. Worst case, you can always put it into the calculator. Okay? And what I want to do is I want to continue to divide by that prime number until I can't anymore. And once I can, I move on to the next one. And then I move on to the next one. And then I move on to the next one. Until eventually, I'm going to get a prime number coming straight down. What is 90 divided by 2? 45. 45 is not prime, so I know I have to keep on going. But it's also not even. So 2 is not going to work. And if it doesn't work, it's not going to work anymore. What's the next prime number? 3. If I can divide by 3, I do so. If not, I move on. If you don't know what 45 divided by 3 is, because it actually does work, put it in the calculator. What does it give you? 15. 15 is not prime, so I can keep on going. I left off on 3. 3 works again. What's 15 divided by 3? 5. And since 5 is prime, I know that I'm done. Not that you have to, but I like to then circle the prime numbers. Yes, ma'am. What do you mean, why is it wrong on there? I don't understand what you're saying. This decimal goes on forever without repeat. Like, instead of, so that we don't have to have a really long decimal and have to, we're trying to avoid rounding. We want to stay exact. So instead of doing I started off the class by putting that on the board, right? Put 4 divided by 6 into the calculator. What does it give you? 0.6666, which fine, yeah, it's going to repeat, but it also goes on forever. So instead of having, because like if you were to then write that on your paper, if you were using that as part of some equation or something, in order to get on your paper, you're going to have to round. So we want to avoid rounding, so instead we just reduce this, and instead of doing the operation, which means that you can then get rid of it, you don't have to write it anymore, we would leave the division there, but just say like 2 over 3. What's going to happen here with the square root, I'm still going to end up with a square root, but instead of being able to bring the entire 90 out of it, I'm just going to bring out part of it. So my next question to you is going to be, hey, take a wild guess what 2 times 3 times 3 times 5 is. It's 90. So I could get the same thing I started with, but rewrite it as 2 times 3, 3. That is the same thing as square root of 90. Now we go to our good friend, the index. When you do not see an index up here, what did we say? What number is there? A 2. In Algebra 1, the only type of index that we really see frequently is a 2. So get used to square roots. So the way that that's used, the analogy I give is, imagine that the radical is some type of like a container, like a jail. And it's keeping these numbers locked in, but they want to breathe free. They want to live the rest of their lives in freedom, right? So in order to be able to break out of this jail, they can't do it by themselves. Xavier can do anything he wants by himself, but these numbers can't. So they have to get into groups according to what the index says. If the index is 2, they have to get in pairs. So do I have any pairs in here? I have a pair of 3s. So I will now circle the 3s. Do I have any? No, hold on. Do I have any other pairs? No. So those 3s were brave. They were able to break out. For every circle, like for every pair on the inside, it's 1 on the outside. So Rosalind, you said 9. No, it's not going to be 9. It's just going to be on the outside. It's just 3. For every 2 that you have on the inside, it comes out once. What numbers got stuck on the inside though? 2 and 5. And you still have to multiply that. So once you've decided who's coming and who's going, if there's more than one number that left, you multiply them. If there's more than one number that stayed, you multiply them. So now the question for you, Soha, would be, and especially since you're able to, it looks like you can store multiple lines there on your screen. Go back and put square root of 90 so that you see that decimal. You got it? Now go and put 3 square root of 10 into the calculator and tell me what you get. And Macy, did you get the same thing? Wakey, wakey. What'd you get? The same thing. So the whole point is that, and a lot of you guys now even have calculators, like Nico's calculator probably does this for him, but these two are the same thing. What this allows you to do is avoid the decimal. Okay, you don't have to get a decimal that goes on forever. It's just that this is considered what's called simplest radical form. The 3 square root of 10 is considered to be simplest radical form. 3 square root of 10, yes. Okay, here's another one. So, since you did so well the first time, and I know that the copies didn't come out that great, but you can always write it in. Can't see it. So, what'd you get when you put 2 square root of 216? Oh man, she got another decimal. Because you have math print probably. Did you just tell you 6 square root of 6? Cheater. Cheater. All right, so because of the decimal, so what Soha wants to do is say, all right, well, look, I can't take out the entire 216, but maybe I could take out part of it. So she's going to do a treat. I want to rewrite 216 as a product of primes. Even though 216 isn't really the biggest number, I would venture to say that most of the people in this room do not know a number that goes into 216 other than 2. Maybe 108 times. Yeah, 4 will, 3 will also, but yeah, and it's not even like you're getting that big of a head start with 9 2. Yeah. So, but anyways, to give you some type of method to follow so that all the children can do this correctly, what I advise you to do is just know your prime numbers and go in order. It's obviously even, so 2 has to go into it. As Emma said, when you divide 216 by 2, even if you can't do it in your head, you get 108. But since 108 is still even, I can bring out another 2, which gives me 54, which is still even, so I can bring out another 2. I'm going to keep on dividing the same prime number over and over and over until I can't anymore. And that happens now because now you get 27. Okay, so now 2 didn't work, I move on to the next one, which is 3. If 3 doesn't work, I move on to 5. If 5 doesn't work, I move on to 7. Eventually, coming straight down, you're going to reach a prime number. 27, 3 does go into 27, 9. 3 times 3 is 9. So, MEC, what do you think you would get when you multiply 3 times 3 times 3 times 2 times 2 times 2? MEC. Huh? 72? No, it's not 72. It is 2. If you put that into your calculator, yes, it's 216, the same number we started with. But now, since I know what this looks like as a product of primes, I can rewrite the radical and write 2 times 2 times 2 times 2. When I can't see the index, what's the index? When I can't see the index, what's the index? 2. So what that index tells you is, in order to break out, what groups do they have to be in? 2 means pairs, so I do have a pair of 2s, but they had to leave one of their comrades behind. We also have a pair of 3s, but they also left one of their friends behind. Sadly, they were lost in the struggle. So what numbers are coming out? A 2 and a 3. Just one, not 2 of them. 1, 2, and 1, 3 are going to come out. But what number stayed in? A 2 and a 3. If more than one number comes, like once we've decided who's coming and who's going, if more than one number comes out, you multiply it. If more than one number stays in, you multiply it. So I get 2 times 3 is 6. 2 times 3 is 6. And then Soha, if you now put 6 square root of 6 into the calculator, what are you going to get? The same thing that we got at the beginning. So the difference is that this is considered to be simplest radical form. You're going to do a slow clap, like in the movies. Alright. You spend a lot of time on a farm? What's different about this? But there's letters, and letters should never be part of math. Hate letters, right? Shh, Xavier. So yeah, well, we have variables here, but the variables are it's no big deal. The variables you're going to enjoy because there's very little math involved. All you have to know how to do is count when it comes to variables. Really? Yeah. And then you have your drink. Now, what I would still advise you to do, okay, the 45 we have to treat like we did the 90 before. And the 216, which what I would do is if you have a calculator and then you're not sure, like I know it's not going to work, but if you're not sure, put 45 in the calculator to see if you can take the square root of 45. When you see that you get a decimal, now let's try to do a tree. Let's see if we can take out part of it. Well, but see, and look, and it's fine. If you want to do it the mental way and do 5 times 9, that's cool, but I don't recommend it. I feel like you're more likely to leave something out. I would tell you to do say, hey, look, 45. I know that's not even, so I'm gonna skip a 2. 2 is never gonna work. But 3 does. 15. 3 does. 5. 5 is prime, so I'm done. So if I were to rewrite this, 3 times 3 times 5. But even though we don't like letters, also known as variables, Isaac, you're friends with the guys too, Xavier? Equal opportunity, huh? He's just friendly. Since a to the 4th power, since I'm rewriting things as a product, and product, Emma quietly told us was multiplication, and an exponent is just like multiplying something times itself over and over again, the same way Xavier keeps on talking over and over again. I can just rewrite this as A. And then when I get to the B's, there's 5 of them, so B, 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 And then when I get to the C's, C, 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 C. Wait, but that's like stupid. Why would you do that? Okay, then don't. I don't. Hey, kids find that it helps. So how was that confusion face? You don't know how I got all those? It's just the exponents. A to the fourth means it's 4 A's. B to the fifth means 5 B's being multiplied. So now everything here is being multiplied. So the index tells me to get out any pairs. So let's go pick pairs. I have a pair of 3s. The 5 has nobody to play with. It's like the opposite of Xavier. There's a pair of A's. I have a pair of B's, but one B gets left behind. And in the C's, I was luckily able to break out all of the C's. So, Roselyn, what's going to come out? Well, not 2 3s. For every circle, you just bring it out once. I get to bring out a 3. How many A's? 2 A's, because there's 2 A circles. How many B's? 2 circles of B's. And how many C's? Then, since we weren't able to bring everything out, we have a square root. What's staying on the inside? A 5 and a B. But I don't want to leave it like that, because we said that if, when we're done, once we figure out who's coming in, who's going, we multiply. Now, nothing here can be really multiplied. You can't multiply 5 times B, and you can't multiply 3 times all those variables, but what you can do is rewrite the variables with exponents. A is A squared. B is B squared. C is C to the third. The inside stays the same. Any questions there? You writing all this down, Xavier? So you can knock it out of the park on the quiz on Thursday? Last one. This is the last one on the notes, but I wanted to at least do 1 or 2 from the homework. I don't know if it seems like we're encountering some obstacles. Okay, so on this one, it looks like the -5 already broke out, but I want to see if I can break anything else out. But unlike the rest of them, there's something different about 81 versus all the other numbers that were stuck on the inside. It is a perfect square. And Soha knows that because she's used to putting stuff in the calculator. And when she puts square root of 81 in the calculator, what does she get? 9. So, and look, if you want to do a tree with 81, it's going to work. But you just don't have to. You can get the -5 that's already there and break out the 81 in the form of a 9. But I still have a square root that had an XX in there. The x squared was XX. But to get out of a square root, I need pairs, and I do have a pair of x's. So I have the -5, I have the 9, I have now a single x. What's left on the inside of the square root? Nothing. So guess what? I don't have the square root. If nothing is left inside, you just don't need it. Yeah, correct. Very good. It's on the outside already. All this is to figure out what I can bring out. The -5 was already outside. Now, what I will do is, now that I've decided, no, it's impossible. They can't. Now that I've decided who's going to come and who's going to go, now I have to multiply. I can't leave it like this. What's -5 times 9? -45. So what I was, I still have like a minute or two before. Hold on, hold on. You're not doing a very good job of holding. So if I go to Delta Math, let's take a little cruise around the assignment for this week. Okay, so look, watch. Express in simplest radical form. It gives me an 18. So this is just year 9. This week is on Delta Math. So 18 is even. When I divide it by 2, it gives me 9. 9 is 3 times 3. So that means I can bring out the 3. What's going to stay on the inside? 4? No, not 4. 2 is going to stay on the inside. 2. So this is a new site for a lot of people, including me. So just so you see, I typed the 3. It looks like here they give me the benefit of a square root. But if ever you don't see it, like what you need, they have this keyboard thing which has a lot of symbols in here. Well, let's see, 3 square root of 2. Submit answer. Check. Yay. So, why did it say 16? They use a different thing where like they use perfect squares, but don't worry so much about the work. Worry about that we ended up with the same answer. Can we stay seated, please?